This is our fifth lab, right? So I have one to go. And this is very important type of, also it is like a technique that we are using for the chemicals and how to extract it, how to dissolve it in the proper solvent and then extract it from the organic and also a water layer. So aqueous layer, usually it is the water. So what we are going to do today is we are using methylene chloride. Methylene chloride has to stay under the hood when you are going to heat it. In other words, evaporate. It has to be dealt with very carefully because it is also has some hazardous, one of which is like, cancer. If you are going to use it on a very, very long term, right, like, frequently, use your the gloves and then wear, luckily we have our mask also and goggles, so be careful dealing with the methylene chloride. What we are going to do, I tried to copy whatever you have in the experiment, and it should be with you. You should have had it like a week ago. So what we are doing today is we are going to dissolve a certain amount of the caffeine, which is already under the hood. You can see all the chemicals under the hood, kept all the time. And after you weigh about, as you can see here, so this is the amount that you try to be like, approximately, not necessarily 100%, but try to be as close as to the value. And then dissolve it in 4 milliliter of distilled water. So all the tables should have distilled water bottle. And you can measure it. You have all the other equipment like cylinders and everything in your drawers. And then you're going to mix it. Maybe if it is not going to be 100% dissolved in water, although we expect that because it has a lot of like the heteroatoms, like the carbonyl group and the double bond nitrogen. So we expect it to be what, like dissolves. In other words, it is going to dissolve in water as a polar compound. But in case if it is not going to be dissolved, we're going to bring it up into a very gentle heating to dissolve everything. So we try to dissolve everything in the water, okay? After you make sure that it is 100 or almost dissolved, then what we are going to do, we're going to add the methylene chloride. And in this case, we are getting into the extraction part of the experiment. So what we are going to do, we are going to have 2 milliliter portion on 3 times, okay? What we are having, we have the centrifuge tubes, which is over there on the back bench. You're going to have the mixture of the water, 4 milliliter, right, with dissolved caffeine. You're going to add 2 milliliter to the first. This is the first wash. It's like you are rinsing it, okay? We're going to give it a good rinse. We also have the vortex over there to mix it. And after you mix it together, you're going to let it to stand a while, and that will have the separation between the aqueous layer and the organic layer. The reason why we're going to do this 3 times, can somebody tell me why? Why do we have to do it in 3 times? It says here in 3, with 3 times of 2 milliliter portion. What we are trying to do now, if we have the caffeine in the water layer and we wanted to extract it to the organic layer, right? So this is it. This is the whole entire technique that we are using today, is to extract the caffeine from the aqueous layer to the organic layer. That's the purpose of our own technique today, extraction and drying. Isn't that what it's called? So that's basically what we are going to do today. We are going to extract the caffeine, which is organic material, right? Organic substance. It is going to be extracted from the water layer into the organic layer, okay, which is methylene chloride. So we do it 3 times because we wanted to extract as much as possible of this caffeine that you dissolved in water to extract it into the organic layer, okay? Sometime when we shake it vigorously, it is going to create an emulsion between the 2 layers, the water layer and methylene, okay? Now, what do you think? Which one is going to be we're going to have 2 layers. So what we're going to have, if we are using the centrifuge tube, okay, so we're going to have 2 layers. One is the organic layer, which is methylene chloride layer, and the other one is the aqueous layer, which is the water layer. Which one is more dense, methylene chloride or water? Now these has to be read and found ahead of time. It's a pre-lab, right? We should know the differences between those 2. Anybody knows? Which one is more dense? Water or methylene? Methylene chloride. So the lower layer is going to be the methylene chloride. And the water layer, which is at the top, is going to be in the top. So what we are going to do, we have the Pasteur pipette, the glass one in the back. We used that before. So what you're going to do, you're going to go all the way to the bottom, and there is a bulb, like rubber bulb here, and then squeeze it before you insert it, right? And then you start extracting the methylene chloride layer, leaving that guy, which is the water layer. This is number 1, right? Then you go to the second wash. You add another 2 ml of the methylene chloride to whatever left over of the water layer, not the methylene. Put the methylene on an Erlenmeyer flask. And then you're going to wash the water layer with another 2 milliliter of methylene chloride. Shake it in the vortex, let it stay still, and then extract the lower layers the second time. You do that for the 3rd time, okay? After you extract this, which is the methylene chloride layer, into an Erlenmeyer flask, put it on this side, all right, with the methylene. In other words, we think it is like a pure, only methylene chloride layer. And that is going to be with caffeine. You may remember, right? Because we are trying to extract the caffeine from the water layer, that it is going to be extracted to the organic layer, and then bring it into the Erlenmeyer flask. 3rd time, we do the same exact thing. And we bring all these 3 times rinsing. Think about it like you are rinsing, okay? And then bring that. Then we are going to have the drying. And the drying agent, we have to dry it because you might see during the extraction, we might end up having a couple drops of water will be transferred from the centrifuge tube into the methylene chloride. So in order for us to make sure that everything is going to be dry off the water, we're going to have the anhydrous sodium sulfate drying agent. We're going to have the tip of the spatula that you have, the powder that you have it under the hood, which is the anhydrous sodium sulfate. It is going to absorb those drops of water from here, okay? So then, when it is absorbed, it is going to be settled in the bottom here. It's going to be settled in the bottom, okay? And this is now not anhydrous, it is a hydrous sodium sulfate, okay? So it is going to be like clumping over there, absorbing the water molecule, keeping the solution clear and dry. That's the drying step, okay? After you dry it, make sure it is dry. You are going to take that, pour it into another container, or like in an Erlenmeyer flask, and then we are going to take it to evaporation. Sorry, that's what it is. Evaporation of the solvent, because we are going to collect the caffeine back again, and we are going to calculate the percentage that you transferred from the aqueous layer into the organic layer, and we're going to see the error, percent error, okay? Percent error is, we should know that, like, you know, we have transferring error, we have like human error. When you transfer from one to the other, you might lose some of the chemical. So this is basically what we are doing today, okay? Now, based on the solubility, a good solvent, and this is recrystallization. Sometime we are going to go into recrystallization. We usually look for the good solvent. The good solvent, it is going to be over here. Good solvent, it is going to be very soluble of the chemicals when it is hot, but it is going to be slightly soluble when it is going to have it in the low temperature. So if we start with 0 all the way here, we're going to see that the solubility is, for a good solvent, is going to be at higher when we have a high temperature. All right? Looking at the poor solvent, it is going to be almost all soluble at all times, all temperature degree. So this is not a good solvent to be used for recrystallization. This is from the solubility point of view. We know solubility is the amount of the solute dissolved in a given amount of solvent at a specific temperature. When we have chemicals, and this is a powder, sometime we're going to prepare that, and this is what we're going to do next, like in a semester. We're going to prepare a crude meaning non-pure 100% or non-pure product, and could be probably has any of the starting material or byproduct, so we need to recrystallize it. That's called recrystallization. And according to this particular diagram, we are going to pick and choose the mixture, probably sometime mixture of organic solvent or one solvent that it is going to give me. When we are going to mix it with the chemicals, it is not soluble at room temperature, but when we heat it, it is going to be totally soluble. Then what we do, we're going to re-cool it back again. It is going to bring up only the powder, or like, you know, the solid of the given or required chemicals, leaving all the impurities in the solution. So this is like, you know, something, or like the purpose behind the solubility and the crystallization. Do you have any questions? So hopefully everybody was able to read the procedure. I tried to summarize it over here. So this is what we start with, and then we are going to mix it with the water. If it is not dissolved, I'm going to bring the hot plate, and then we're going to have a like water bath. Keep it like gentle in case if we are not going to be able to have the caffeine 100% dissolved. And then after that we go into the extraction, and after we shake them, like, you know, shake it, make sure that it is going to be dissolved in water. And then we go from extraction. From the extraction, we're going to go into the drying step. And this is basically what we are doing today. Okay? You can start. You have all the chemicals and the under the hood. You have all the equipment you need, some of which are on your bench. The others are in your drawers, and you can use them. So here we are. Now we are in the process of measuring 70 milligram of the caffeine. We're going to add it into the centrifuge tube, and then we are going to add 4 milliliter of the water. And now this is what we are doing. And then after that, we're gonna have 4 milliliter of the distilled water. With this cylinder, I'm going to weigh 4 milliliter, measure 4 milliliter of distilled water. Okay. Can I have it? So this is basically what we have. We have 70 milligram, which is 0.07 gram. We added the 4 milliliter of water. And can I have the cap? Cap it. Cap the tube. And then we're going to mix it. Try to dissolve it 100%. So if it is not dissolved, as you can see, it requires some. I'm going to take it to the vortex to mix it. So that's all right. Still have some here, so I'll take it to the vortex. So we are in the process of dissolving the caffeine in the centrifuge tubes because it is not going to be like, it is not 100% dissolved. So that's why we are heating it. Put it in a hot water bath. Give it some time to dissolve 100%. And then after that, you are going to add methylene chloride, 2 milliliter, 3 times, rinse it. And then we're going to see, the extraction of the caffeine into the methylene layer from the water layer.
So this is what it should look like now. So we dissolved all of the caffeine. Should be kind of clear. And now we're going to add 2 milliliters of methylene chloride. And now we have 2 milliliters of methylene chloride that we're going to add to the caffeine and distilled water. And now you mix. So after shaking, you're going to let it sit so that the 2 layers can form.
So this is the 2 layers. As you can see, we did add 2 milliliters of the methylene chloride to our mix, the mixture of water and caffeine, and we were able to see 2 layers. Now we are going to remove the lower layer because methylene chloride is more dense than water. So the lower layer is the organic layer and the top layer is the water layer. So I'm going to prepare the Pasteur pipette and then try to remove the lower layer. So what I'm going to do That's all right, I was able to get it. This is the two layers here. The lower layer is methylene chloride.
Yeah. We can't see.
Okay, take it up. So I'm going to go all the way, squeeze it. Can I have everybody here, please? You are able to make it, right, to do it? So we're gonna squeeze, insert it all the way through to the lower layer, and then let it go. So we're going to transfer it to the Erlenmeyer flask until we have everything is going to be transferred. And then I'm gonna do the other time all the way. And then we do the same thing. You can see that it started. Now we're going to add another, although there are some over there, but I wouldn't, because then I'm going to take a lot of water, and I don't want to do that. So now you are going to add another 2 milliliter of methylene chloride under the hood, and then do the same thing. You
And
can
this is
see
the one
the
that we
chemicals
extracted.
here started. Look, it's already, because the methylene chloride. What is the boiling point of methylene chloride? What's the boiling point of methylene chloride? I'm asking you, girls. The chemicals, you prepare the chemicals. What is the methylene chloride boiling point? It's very volatile. So what's the boiling point of methylene chloride?
I think it's like 98.
Sorry? Very, very low. Right, it's volatile. So you have to be careful when you put it on the hot plate, because sometimes if it is too hot, it is going to burst into a flame. So we have to be very careful with that.
So this is the second round of the methylene chloride. And they're forming the two layers again. So we're gonna go and put it on the vortex.
You actually can see a part of it, because what I did is I added some of the salt. In other words, everybody, can I have your attention, please? Now you should know the hydrophobic hydro. So now you're doing the same thing with the second. Did you give it a good mix?
Yes.
All right. So we wanted to transfer most of the caffeine from the water layer into the organic layer. That's why we want to mix it. And then you see here it's very clearly, like, it's clear that it is going to have the two layers. Okay, you see that? I'm going to mix it again. This is the third time or second time?
Second.
So that's the second time. I'm going to wait, leave it here, and then we're going to transfer it to the Erlenmeyer flask and do the third time. And after that, we're going to use the drying. Okay? Give it some time to rest, to settle, and then you're going to do the same thing. You're going to extract the lower layer.
How many of these are we going to use? Sure. Want to transfer it?
first, then put it inside and let it go.
Okay.
So that's the third time, right?
Yes.
We're adding another 2. Can you see? Another 2 mil of methylene chloride. That's the last addition, right?
Mm-hmm.
And then we're going to do the same thing. We're going to shake it, making sure that we are going to be able to extract as much as possible of the caffeine from the water layer into the organic layer. So I'm going to shake it, and then I'm going to let it stay still for another couple minutes until you see the 2 layers are going to be clearly separated. We're going to remove the lower layer again, add it to the rest of our extraction, and we'll take that one, and then we move to the drying part, and that's when we are going to have a couple of those granule of the anhydrous sodium sulfate. That will take most of the water that it could be transferred into that layer, which I believe there are some of these dot, like here, bubbles, that it is some of the water. So that will be removed by the anhydrous sodium sulfate.
I'm showing the little bubbles, the water that you're talking
You
about.
see there are like drops of the water, and that will be sucked. In other words, it is going to be absorbed by the anhydrous sodium sulfate after we finish the third extraction. So you're going to remove that one now, the last layer. Do the same thing. Let's see. I'm going to bring some of the sodium. And the tip of the spatula, we're going to add a little bit of the sodium. You can see how the water is going to be clung into the sodium. You see that? So I need more of it until it is all going to get stuck in the bottom of your, and then leave the clear, pure, dry layer of methylene chloride here. So I still have some of the water there, but I'm going to add more. Seems that we do have a lot of it. Okay, so now I'm going to have the smaller one for that one, 50 mil, the small one. That one here. So we're going to decant, we call it, transfer it hold it without bringing any of the anhydrous now of the sodium. So you see it's stuck at that bottom. You see it, everybody? So this is the water with the anhydrous. Now it is hydrous sodium sulfate. I'm going to decant only the, so this is basically a dry organic layer. Technically it is going to have the whatever extracted caffeine from the water layer into the organic layer with methylene chloride. The following step is we are going to take this now, hopefully we should have, we're going to weigh it when it is going to be empty, that one, when it is empty, and now we are going to weigh it again after we are going to evaporate methylene chloride. Methylene chloride boiling point is very low. It's like room temperature in the 30s. So we have to be very careful because it is volatile. Volatile meaning it could be flammable also if we are going to heat it. So therefore, the heating is going to be conducted under the hood, on the hot plate, on top of the water bath, not directly on the hot plate, because could catch a fire. You have to be very careful with methylene chloride or ether as well, diethyl ether or methyl ether, because those are flammable and it could burst into a fire if it is going to be put on any hot plates. So that's basically what we're going to do next. We are going to take that Erlenmeyer flask on top of the, in a water bath, trying to evaporate the organic layer of methylene chloride. And hopefully we will be able to collect the caffeine that we extracted through this process today. So you see when you're going to just hold it here, so this is what we got. This is the caffeine that we are extracted. So what we had after we dried it with the anhydrous sodium sulfate, we decanted from here, so everything that water is here. We took the whatever, the pure methylene chloride layer, put it on a water bath, hot water bath, and that is what happened, actually evaporated methylene chloride, and this is supposed to be the caffeine that we weighed. Now we are going to have the percent error from whatever you weighed, and this is after you weigh it divided by the actual, the initial, you will be able to get the percent. We will see how much we lost through transferring from one container to the other. So that's a very good idea that we're going to take how many percent of human error or transferability or anything like that. So we're done with today. This is going to be wait until we make sure it is cold before we take it to the balance, and then we're going to weigh that, and we take off the weight of the container, which is the Erlenmeyer flask of 50 ml. We will be able to weigh the final pure extracted caffeine from methylene chloride. Thank you very much.